There are signals from many radio transmitters in this band inducing signal voltages in the aerial. The RF amplifier selects and amplifies the desired station from the many. It is adjustable so that the selection frequency can be altered, and this is called tuning. In cheaper receivers, the tuning is fixed and the tuning filter is wide enough to pass all signals in the FM band. The selected frequency is applied to the mixer. The output of an oscillator is also applied to the mixer. The mixer and oscillator form a frequency changer circuit. The output from the mixer is the intermediate frequency, which is called IF. The IF is a fixed frequency of 10.7 MHz. No matter what the frequency of the selected radio station is, the IF is always 10.7 MHz. The IF signal is fed into the IF amplifier. The advantage of the IF amplifier is that its frequency and bandwidth are fixed no matter what the frequency of the incoming signal is. This makes the design and operation of the amplifier much simpler. The amplified IF signal is fed to the demodulator. This circuit recovers the audio signal and discards the RF carrier. Some of the audio is fed back to the oscillator as an automatic frequency control voltage. This ensures that the oscillator frequency is stable in spite of temperature changes. The audio signal voltage is increased in amplitude by a voltage amplifier. The power level is increased sufficiently to drive the loudspeaker by the power amplifier. This is the simple circuit of an FM receiver. It consists of this antenna which collects the radio waves sent by the radio station. It then sends it to this BJT which acts as the RF amplifier. This here is a local oscillator which generates a local frequency of its own, which is mixed into the signal sent by the radio stations through a mixer. The mixer in this circuit is the second BJT over here. The function it performs is that it acts on both the frequencies, that is the original frequency and the local frequency, and it sends it forward to the filter circuit, which is an RC filter. Now this is an RC band pass filter. It helps to get the desired frequency. It then sends it to this op amp which acts as an amplifier over here. The demodulator is this one, which converts the signal into audio waves, which are further amplified and then played through a loudspeaker. Now let us understand how do we tune into a particular radio station. The filter decides the frequency to be tuned. By changing the RNC values, any omega can be tuned. RNC defines the resonant frequency, and the filter allows only waves having the frequency equal to the resonant frequency to pass, thus blocking the rest. And this is how we tune into a particular station.